first experiment, it's two NOR gates connected to each other. This IC is all NOR gate IC. So as you see in this diagram, there will be a VCC connection and a ground connection. So the VCC connection is number 14. So the VCC must be connected to the VCC input, and the ground of the orange color must be connected to the ground. Then there will be input 2, 3, and the output will be 1 for one NOR gate. So since this they ask two different input and connect, the output will be X. So number 2 and number 3 will be connected to the inputs, and number 1, which is yellow wire, will be connected to the series, and then the both inputs will be series to each other. So these two white wires is the series of the inputs 5 and 6, and number 4 will be the output X. So once you test it out, when both zeros are zeros, so the X will be 0. When A is 0 and B is 1, the output of X will be 1. And when A is 1, B is 0, the output will be 1 also. And when both of it is 1, as you can see, the output will also be 1.
Hello, I'm going to explain for the schematic for circuit 2, which is this one. And this is the result. As you can see, this is the circuit which is connected, same as the diagram. So according to our prediction, when the input is 0, then the output will be 0. If B is 1, the output will be 1. Or if A is 1, the output will also be 1. If both A and B are 1, then the output will be 0. Called as exclusive OR.
So in this experiment, we need to connect 4 NAND gates as a series of inverter. So firstly, we connect the IC74HC00 into the backboard. Then after that, we connect the output from the clock module out, and we series out the input and the output together. And after that, we get the output. Before that, we need to set the clock module 500 kHz, as you can see in the clock module. Then after that, we connect both of the input and the output to the oscilloscope. Then after that, we need to press the auto. After that, we get this graph, these two graphs, which is this one is input and this one is output. Channel 1 and channel 2, input and output. And after that, we select the square wave, this second option. Then after that, we again stop again. We cursor, and we select this one. Then manual. Then after that, we select this option, and then move to this point, and another one, graph B, move to this one. As you can see, the result. The DOL of is 80 millivolts, which is same with our digital oscilloscope, and then the DOH is a 3.36 volt, which is you can see in the oscilloscope.
Now we want to measure the time propagation delay. So first you want to measure TPHL. For that, as you can see, this is a high-end graph. So at the oscilloscope, you choose a high-end graph, and then you zoom out a bit so that you can see the graph, and then you stop so that you can freeze it. Then select the cursor, you select manual, and then for the type you must change to time. If it's at voltage, you must change back to time, and then you adjust your cursor A until the middle of first graph, which is your input graph, somewhere around the middle. And for your cursor B, you adjust for the second graph, somewhere around the middle also. You can get around 59 nanosecond the time propagation delay. So that will be our TPHL. Now for the TPLH, which is the low end graph, you select the low end graph. So you select this, and then you freeze it, then you basically repeat the same thing. Make sure this is time. So for the second part, you zoom out a bit. Okay, then you select your first cursor, adjust it to the position around center, and select cursor B, adjust it around center. So it will be around here. So this will be your time propagation delay, which is 48 nanosecond. And for this, both of this TPHL and TPLH must divide it by 4 because there's 4 NAND gates. You are finding for one NAND gate. So after divide by 4, that will be your final answer. Thank you.
So this is our circuit connection. So first of all, regarding to the figure in the lab, we need to connect series, which all the components in series, which means that VDD. Then after that we connect to the LED diode. Then after that the resistor. Then NAND gate with the opposite position. And after that, according to our calculation, we get the suitable resistor to do this experiment is a 120 ohm. Okay, now back to our connection. Now this VDD, we connect VDD. Then after that we make sure the polarity of the LED is correct, which means that this one is positive and this one is negative. And then we connect series to the resistor. Then after that we again series to the output of the NAND gate. Then after that we take both of the pin 1 and pin 2 series out as an output to the ground. Then after that, here is we power up the IC. Now let's see the result. 1, 2, 3. As you can see, the result, the LED is turned on, which means that our lab, this proves that our lab is correct.
This part 4, we found that the circuit that can fulfill this condition is this circuit, but we don't have the type of circuit, the IC that can fulfill this circuit, so we derive to this circuit, which is 4 NAND gates. 3 NAND gates have 2 inputs and 1 NAND gate have 3 inputs. So according to here, we use this IC to have, this IC is responsible for 3 NAND gates for 2 inputs. So after that, the output will go to this IC. This IC accept 2 inputs and the output will